Thanks, Guoliang, for this nice introduction. Can people hear me? The microphone works? Okay, great. And today is my great pleasure to be here on the ACM IoT Day. And especially in this morning's session, we heard the keynote speech by Dr. Feng Zhao and the two previous speakers discussing about AI on devices. And my talk will be a little more general. And the title, of course, is called Embracing Ubiquitous Connectivity and AI, the Next Era of IoT. As I mentioned, I work both as a professor at McGill University and also at Samsung AI Research Center. So for this audience, I assume everyone knows what is IoT and what are applications. And of course, IoT extends the internet connectivity into the physical devices. And it's called the Internet of Things. So the things refers to the devices embedded in the physical environment. And the internet, of course, refers to the connectivity. And there are many, many applications. For example, healthcare, manufacturing, transportation, retail, mining, construction. And during the past 10 years as a professor and also work in the industry, I worked in several of the areas as applications. And there are three major components of IoT. The sensor and the devices refers to the things. Of course, it's very important because it can sense the physical environment. And the connectivity is another very important component. And traditionally, IoT and the researchers in this community studies a lot on that. They are experts, for example, on Wi-Fi, Bluetooth, Zigbee, and many other new protocols on the communication and connectivity side. And for me, I think without a real application or the use scenario, IoT will not fly. So the service provided or the goal an IoT application will provide to help the human being is very important. So this figure shows the growth of the IoT devices. And of course, we see this increasingly increase the number of connected IoT devices in the whole world. And of course, it's projected to 2025. And as we can see, by 2020, the forecasted number of the connected devices will reach to around 31 billion. It's a huge number. So the title of this talk is IoT in the New Era. Of course, it's too big, and I'm only one of the researchers. And as I mentioned, the three components, the things or the sensor and the devices are very important. A lot of researchers in other areas, in devices and in physical sciences, are developing a lot of interesting new sensors. And they can help us to sense the physical environment beyond the current sensing we've already been familiar with. And this is beyond the talk. And I will focus on the connectivity and AI today. For connectivity, we need to keep constantly improve it. And we need for IoT application in the next decade, the communication needs to help us communicate among the devices, all with the infrastructure more easily, and the coverage is much larger because it can make the whole IoT system more scalable and also easier to deploy. And of course, it also needs to be more energy efficient. I will discuss more later. And the solution is, of course, we call advanced connectivity technologies, including the hot buzzword like, for example, 5G, or other connectivity technology, including NB-IoT, LoRa, Sigfox, and many you have heard about before. And on the third pillar, which is a service, we need to make the services more intelligent. And this is echoed by the keynote speech this morning and the previous two speakers in this panel. Of course, the solution is that we need to embrace artificial intelligence. So first, let's discuss about IoT and AI. So what benefits can AI provide to IoT? It's very simple. AI will make the IoT applications more intelligent. The intelligence, of course, is very important. We like to call the things smart things. And also, if used correctly, AI can make IoT applications more secure and reliable. And on the flip side, so what benefits can IoT provide to AI? So in fact, a lot of people think that AI now is the new era, and there are ups and downs of AI during the past several decades. And the real landing application, or the killer application, is very important for AI. So IoT services, in fact, are very important killer applications for AI. So that's why we're here today. And in fact, IoT applications also generates a lot of data, and because it sends from the environment. And those data can be used by AI. And in fact, based on that, it can enable new discoveries. So AI and IoT together, many people call now the AI IoT, has a lot of new applications. For all the traditional IoT applications, if you add either smart or intelligent, then it goes to the new application. For example, smart healthcare, smart manufacturing, smart retail, smart city. And I want to give two applications, especially for the places I worked before. So I worked as a professor in Lincoln, Nebraska for 1 year. And here it shows another startup. It's called Quantified Agriculture. They use IoT and AI to do the remote tracking and monitoring of sick and also pregnant cattle at various stages. By using the IoT, the sensors put on the cattle, and also using the AI technology running in the cloud, so they can help to identify sick animals much sooner. This will lower the morbidity and the mortality of the cattle, which is extremely important in the farming industry. Here's another application. It's called Chronolife in Paris, France. And it has launched a smart vest, which you can buy. It detects 6 physiological indicators in real time. For example, the ECG, your heart rate variance, abdominal respiration, pulmonary impedance, the temperature of yourself, and also the physical activity. And then by sending those information, running the AI machine learning algorithms, they can predict the upcoming serious conditions, for example, myocardial infection. And the second part is that in addition to AI, the advanced connectivity also plays a very important role for IoT. And here I want to focus on the new technologies. And the first category is called low power wide area network, or LP1. And it can provide the long range data transmission, and that also enables the high coverage, and it's very important for a lot of new IoT applications. The second one is 5G. It enables high data rates and also bandwidth and also the coverage. It will bring us the low latency and also the energy consumption. So by embracing all those new advanced connectivity technologies, what benefits can we bring to IoT? Of course, it can bring low power or the efficiency of the reliable communications. And on the bottom is a figure showing that the difference comparison among the traditional technologies, communication technology, for example, Wi-Fi, Bluetooth, Zigbee, or Bluetooth low energy. And on the right-hand side is the new technologies. For example, LTE-M, which is part from 3GPP, and under the machine-to-machine communication under 5G, and the NB-IoT, narrowband IoT, a lot of people here are doing research. And the LoRa, similarly, and also Sigfox. Its comparison in terms of the data rate and the power consumption on the y-axis, and also the range of communication range on the x-axis. So by embracing the advanced connectivity, we can also enable a lot of new IoT applications. So for example, self-driving or autonomous driving and the connected vehicle is very important. And also the global logistics and supply chain, automated agriculture, connected factory, and many things we discussed in this morning and the whole day. Again, I want to give you several applications. One is called precision agriculture, and a company in San Jose, California, it's called WaterBit. It uses IoT, especially using the new communication technology like LoRa, you can see that, and also LTE and LTE-M to do the precision, for example, one application is irrigation. So it can, using the sensing devices, to monitor remotely the soil conditions, especially the moisture and the water pressure on the devices. And then it takes into account other conditions. For example, the weather conditions and also the stage of each different plant, in which stage. Then it's running intelligent algorithms. Then it can control the precise irrigation to the crops. Because, for example, if it's going to rain the next day or in the afternoon, you don't need to irrigate a lot. Otherwise, it's bad for the crops. And here I want to emphasize they use a lot of new connectivity technologies. For example, between the carbon, which is the device using the sensing, and the base station, and they call the gateway, they use LoRa. And then between the gateway and the dashboard, which is in the cloud, they use LTE. And another application is connected vehicles and self-driving. So during the past 4 years, I have been working with General Motors research on a very large project called vehicular communication. We use vehicular communication technology, including the DSRC, and the new one is 5G technology, to help for reliability and the better communication among the vehicles and also the vehicle to the infrastructure, to the roadside units. So if you're interested, we can discuss offline, and this is the project webpage. And in the later part, so we use this technology to help to do assisted autonomous driving. And in fact, using LiDAR and also camera alone, and also sonar alone, you cannot achieve the fully autonomous driving in level 4 or level 5. And the cars, they need to communicate. And in fact, if the cars can communicate, and then you can avoid the recent accidents, like Google Waymo had in Mountain View, California, and also Tesla in Florida. Again, we can discuss in offline the details. So now let's switch gear a little for the challenges and possible solutions, because we're researchers, we like challenges, and we want to propose solutions. So several of the challenges has already been discussed in the keynote and also by the previous two researchers. But I will give a high-level bird's-eye view. So on the AI side, as I mentioned, AI is very important for the future IoT applications. The first challenge is resource-constrained devices we have. But AI-powered embedded devices needs more resource for computation. And for example, Nick's talk already mentioned that, and dive very deep. So the current IoT devices, we all know that we have very limited battery life, low processing capability, and limited memory and storage. And let alone, we want to run advanced AI and machine learning algorithm on top of that. And as we know, the current AI machine learning, especially the deep learning, they require a lot of processing capability and memory and storage. And the second part, which hasn't been covered by the previous talk yet, is I call data quality. And in fact, if you run AI machine learning algorithm, especially for real applications, and there are many, many things you need to handle. And even on the data side, there are many problems we need to address. One I called is that imbalanced classes of data. For example, if I'm running anomaly detection using IoT devices, and the anomaly, of course, doesn't happen that often, then the normal case and the anomaly case is imbalanced. But imbalanced classes of data is unlike the textbook approaches, okay? They give you the data, and then you have really balanced of the different classes. And the algorithm runs very well. But however, imbalanced classes of data, and the typical algorithm will not run very well. There are many reasons for that we can discuss offline. The second problem I call the data scarcity problem. So we use ImageNet a lot in research, but that's already labeled data. And in real-world applications, especially if you want to start a company by yourself, and the data label thing is very time-consuming and also labor-intensive and costs you a lot. So how to obtain those data and how to use a limited classification of the labeled data and still let your AI and machine learning algorithm running very well, especially on top of the IoT devices. It's a big challenge. The third one I call is the data heterogeneity problem. For example, if you want to do localization, and we have so many different sensors, and like Wi-Fi sensors, and other sensors like acoustic sensors, and each one you can run machine learning algorithm or AI to do localization. How to combine these together, and using different kind of data. Some are maybe non-categorical, the other is categorical, and running together and to achieve better accuracy and efficiency of the algorithm. It's also very important. And the list, in fact, can go on. Now I want to give you some of the other challenges, like advanced connectivity. And the firmware, of course, on top of the IoT devices needs to be updated to prevent nodes from becoming security holes. But it's well known from the sensor community and IoT community, the devices are harder to manage and update. Even using the newer communication technologies, for example, LoRa and Sigfox, it's optimized for the upload bandwidth, not for the download bandwidth. Because IoT devices think, okay, we collect all of data and transfer to the cloud. But in fact, if you need to update the firmware, you need the download capacity and to update your firmware. And in fact, using large-scale IoT devices, the substantially larger attack may surface. And this is, in fact, echoed by the recent a lot of incidents, especially if you heard about it, Mirai. It's an IoT malware, and it's open sourced, unfortunately. And it affected many of the IP cameras and home routers and turned them into the botnet. So this is the problem the whole community we need to face and solve. And also, there's new privacy issues. The rise of 5G could lead to even worse location data privacy issues because the Pico cells and the phantom cells install for the 5G. And also, last but not least, is the large amount of data collected may bottleneck the backbone. And because 5G network is very fast and collecting a lot of data, if you don't do on-edge AI or the pre-processing of the data, it may easily overload your bottleneck of the backbone, even using optical network. So that's another problem. So the next 2 minutes, okay, then I will give you some of the solution directions. And for example, efficient hardware, you heard about FPGA and also the Google TPU. Now the version 3 is there for IoT devices. And model compression, we heard during the press talk this morning by Ethan and Nick. And there are many different technologies. For example, Ethan's talk is focusing on the quantization and the knowledge distillation and the pruning. There are many ways to do that. And also, on-device AI and edge computing is on the rise of the horizon. And for data quality, as I mentioned, for example, data imbalance I mentioned, then there's the open oversampling or upsampling technique and also undersampling techniques we can use. But still, it doesn't solve the problem all. We still need research in this area. Data scarcity, and today I'm very happy that Nick is a colleague at Samsung Research Center. We have, and Ethan, and working on social networks and also search engine. So during the past 2 years before Samsung, I take a leave from the university working as the chief scientist of the largest dating app and the social discovery app in the whole world. And so there we do a lot of face recognition and on-device AI because if you know the dating app called Tinder, so we have a lot of facial data and it's also an app. And then we have the problem, it's not an IoT company, but it has all the problems we are seeing today. So we use, for example, transfer learning is one way we use that to solve partially the problem that Ethan discussed today. And the data heterogeneity, and I don't have time to discuss more, but we can use multimodal learning. And the last is that I want to show in the future what is my vision of IoT we are going. So currently, state of the art, and we discussed a lot about smart home. Like Hair is one of the leader here. Samsung is one of the leader in smart home. And Amazon, of course, Google Nest is also one of the leaders. And during the past several years, so I helped started a small startup in Montreal. And in fact, both Marco and myself are on the advisory board of this small startup. And it's using Wi-Fi, it's device-free, based on indoor localization and motion analytics. There are a lot of applications for that. We just got another $3 million funding from Intel Capital. Again, if you're interested, we can discuss offline. But this is the work in the category of smart home. And the next step, in fact, people already begin to do a smart campus and a smart factory. For example, Cisco has a smart campus or connected campus initiative. And many of the university already is on board. For example, Duke University in Australia. And also Samsung has a next plant, it's a smart factory using AI and connectivity for the next generation of the factory or the manufacturing. And also, not far from here, it's 30 miles away, that's near the airport when you came for ACM IoT Day and MobiSys. So the city of Songdo, I don't know whether my pronunciation is correct, was the world's first smart city prototype. And Dubai wants to implement the smart city within 2 years. And also Alphabet or Google is helping Toronto to deliver in 2023. It's called Sidewalk Toronto. It's another smart city. And what I see for the future is that we are going from, thanks for the researchers here and the IoT. So smart home, and we are transitioning to smart campus. And then it's smart city, it's on the horizon. And the next will be the smart planet together. And this concludes my talk. Thank you.